atoms. This module will help you to understand the Dalton's atomic theory, Rutherford's model, Rutherford's gold foil experiment, Bohr's theory, subatomic particles and their discovery, atomic number, mass number, valence electrons, noble gases, radioactivity. Dalton's atomic theory. The theory established by John Dalton says, atom is the basic constituent of all matter. Atoms cannot be created or destroyed. All atoms of the same element are identical and different elements have different types of atoms. Chemical reactions occur when atoms are rearranged. Compounds are formed when atoms of two elements combine to form a bond. Rutherford's atomic model. Rutherford described atoms as having a positive nucleus at the center and negatively charged electrons orbiting around it with a lot of empty space. Most of the mass was concentrated in the small nucleus. He derived this conclusion from his famous gold foil experiment. Rutherford's gold foil experiment. Rutherford and his associates performed an experiment. J.J. Thomson's model of an atom states that the beam should always pass directly through the gold foil. To confirm this, a zinc sulfide screen was placed behind the foil as a backdrop to observe the activity of alpha particles. The experiment was conducted in dark to avoid any interface and observed through a microscope. A beam of alpha particles was bombarded at the gold foil. Though most of the particles passed directly through the foil, there were few particles that deflected by about 1 or 2 degrees and some more than 90 degrees. Rutherford observed that alpha particle being negatively charged deflected from its path when it came in contact with a positive charge in an atom. That is why Rutherford arrived at conclusion that the atom must have a positively charged center with a lot of empty space. Bohr's theory. Bohr presented a theory in which he explained the arrangement of atoms in energy shells K, L, M, N and so on. He derived a formula 2n square which can help calculate maximum number of electrons an energy shell can hold. He concluded that this last shell can hold maximum of 8 electrons and the first shell can hold at the most 2 electrons. The moment the shell fills up with 8 electrons, the next electron moves to the next energy level shell. For example, Ne 2,8 occupies energy shells K and L respectively, and the next element Na 2, 8 and 1 occupies energy shells K, L, M respectively. Subatomic particles and their discovery. Proton is a positively charged particle. Protons with neutrons form the nucleus of an atom. It represented as P+, but in chemistry it is represented as H+. A German physicist, Eugen Goldstein, discovered these particles. Neutron. A neutron is a neutral particle and along with proton forms the nucleus of an atom. It is represented as N. Neutrons bind the protons in a nucleus and help maintain the stability of an atom. Neutron was discovered by a British physicist named Sir James Chadwick. Protons and neutrons together are referred as nucleons. Electron. An electron is negatively charged particle. It is represented as E-. The mass of an electron is 1 by 1837 of hydrogen. They have an angular motion and spin around the nucleus, maintaining the stability of an atom. They were discovered by Sir John Joseph Thomson. He established a theory that negatively charged particles need to be balanced by positively charged particles. atomic number, mass number. Now, let's go through some basic concepts. An atomic number is the number of protons in a nucleus of an atom. It is represented by symbol Z, and a mass number is the number of protons and neutrons in a nucleus of an atom. It is represented by symbol A. We can calculate the number of neutrons using this formula. Number of neutrons is equal to mass number, that is A, minus atomic number Z. Valence electrons form chemical bond with other atoms of same or different elements. Na281 can easily give up its highly reactive electron in the last orbital, as it can attain a stable structure, and Cl287 on the other hand can willingly accept electron to complete its octet and attain stability. Therefore, Na and Cl combine readily to form sodium chloride, NaCl, that is common salt. Noble gases have a stable electronic configuration. The gases helium, neon, argon, krypton, xenon, radon are inert or noble gases. They have 8 electrons in their outermost shell and hence attain stability. Helium is the only exception with 2 electrons. Noble gases do not react under normal condition. Radioactive element. Sometimes the nucleus tends to get unstable, releasing protons, electrons and neutrons and energy. These elements are called as radioactive elements. Uranium, radium, thorium, etc. are radioactive. This radioactive energy is used to produce electricity, for research work, sterilize medical instruments and various industrial processes.
Summary.
Dalton's theory suggested that every matter consists of atoms. Rutherford established that atoms consist of a positively charged nucleus and negatively charged electrons revolving around it. The formula 2n squared helps calculate maximum number of electrons energy shell K, L, M and so on can hold. Atoms comprise of protons, neutrons and electrons. Number of neutrons in an atom is equal to mass number minus atomic number. Valence electrons form chemical bond with atoms of same or different elements to form compounds. Noble gases do not react as they have a stable octet structure. Radioactive elements are high energy, unstable elements and release protons, neutrons, electrons and energy.